now we are on track, and we'll have the ELI-MP Center as was planned initially, having the two big equipments, high-power laser system, which I have to tell you because you are from the gamma part, but yesterday was finished also, we have finished all the tests, and the system is working perfectly, and next week we'll sign the document that high-power laser system is operational. The experiments are on track, and now Gamma is on track. So we'll have the kickoff meeting. We have the honor to have today His Excellency, the Ambassador of the United States to Romania, Mr. Hans Klemm, permanent friend of ELI-MP. I think that is already, your first visit was when the building just started. Yes, and now you see, I mean, in the meantime, Mr. Ambassador participated also in nuclear photonics conference in Brasov. So, and we'll have also the honor to have Mr. Ambassador at the workshop organized at Washington, D.C. by Hudson Institute to make ELI-MP known in that environment, which is very important. Washington, D.C. environment is very important for our future collaborations.
The system will actually be open to all fields of applications, including evaluating the use of gamma rays even for medical applications. I imagine that there will even be experiments that consider treatment using gamma rays that could be translated later on into clinical use. And like one other application area is detection of nuclear materials and fingerprinting, being able to use the gamma rays to probe deep into systems and find very small amounts of material inside of a big vessel, for example.
Using gamma rays, it's possible to separate, to determine the isotopic ratios of sensitive nuclear materials. What? Uranium and plutonium. So if there is some claim that is natural uranium, you don't have any method, chemical or physical method, to determine if it's enriched uranium or not. With gamma, you can determine in a couple of minutes what kind of uranium you have. So this is to check, attempt to trespass the borders with illegal materials, and also to determine the ratio in the nuclear power plants. Because right now the fuel, if it's enriched uranium or not, the fuel is changed according to calculations. Nobody knows exactly the good fuel, which uranium-235, is over or not. This will increase the efficiency of nuclear power plants because you change the fuel only when the good one is over. So this is one example. Another example is, as Mr. Fezer was mentioning, there are proposals to produce new radiopharmaceuticals, which cannot be produced by any other method in nuclear reactors or other nuclear reactions. So these are the basic ideas. Of course that we're just discussing, the technology will allow probably to lower the scale. So once this scale will be lowered to the dimension of a truck, in that moment will be very useful for border control, but this is the first one to make, but for sure technology will advance in such a way that will make a compact system. So there are a lot of applications in this respect.
Yeah, perhaps to also comment on that, this is a new tool with unprecedented capabilities. And for example, our X-ray machine that is in operation in Munich, they are in biomedical research, and they have actually developed treatment or a diagnostic method for lung imaging that now is being translated to clinical use based on the development of our machine. And something similar can be expected with this capability as well.